Hello. In this video, we introduce geometry, in particularly points, lines, rays, and angles. Let's get started. So to begin, we introduce the concept of a line, which is a straight path that goes on forever in both directions. Notice when we talk about a line, you'll see an arrowhead on both endpoints, if you will, because it's indicating that we're going on forever in both extremes. On the other hand, when we describe a line segment, you'll notice that instead of two arrowheads at the ends, we have two dots or two endpoints, meaning we basically have cut a segment of the line that would normally go on forever. Okay, then we have a ray here. A ray has one initial point or a terminal point that stops, and the other is an arrowhead, right, at the other side. So it is partially going on forever in one direction, but stopping at the other. Then we have something called an angle, where we have our two rays intersecting at what we call the vertex in this corner here, and they form an angle. Now that angle can be measured using different devices like a protractor and a compass, and what we notice here is that when they come together in a nice 90-degree angle, we'll call this a right angle, and we'll talk more about that in a future slide. But in this case, we wanted to introduce the basic idea that two rays, when they are connected at a single vertex, they rotate to form an angle. We also have something called parallel lines. You see this a lot when you have streets that are laid out that are parallel to one another in real life. Parallel lines, again, are two lines which never touch because they have the exact same slope. Then we have intersecting lines, which may or may not intersect at different types of angles, like a right angle here. Sometimes they're going to intersect at smaller angles or larger angles. But in this case, we have a nice right angle, so we would say that these two lines which intersect are perpendicular or orthogonal. So those are some basic starting points. So we have a point, we have lines, we have line segments, we have parallel lines, we have angles, and we have rays. Below here, we also want you to be familiar with some special terminology involving angles: right angle, acute angle, obtuse angle, and straight angle. Hopefully you've heard of these before, but we just want to make sure you have them in your notes and you're going to be able to recognize what we're talking about. So when we say right angle again, that meant the angle that was formed by these two rays is in fact a perfect 90-degree angle. That's actually very useful in building, right? We'll take a straight edge and we'll try to make sure that we do in fact have a 90-degree angle between, let's say, the floor and a wall so that we don't have anything falling over. That's very important with drywall. On the other hand, when we mention an acute angle, we're talking about an angle which is between 0 and 90 degrees. So that means a smaller angle that is not quite 0, so it's not just a straight line, but it's not quite 90. It's not a right angle as well. Then we have something called an obtuse angle, which is a larger angle than a right angle, between 90 and 180. And then once we go all the way rotating that second ray into a straight angle, we have 180 degrees. Okay, so those are ones that you'll want to make sure you have memorized so you can recognize those definitions in future problems. So when you're ready, let's head over and practice some of these definitions in use. So first application is forming complementary and supplementary angles. So the word complementary, the first few letters here, C-O-M-P-L-E, begin the word complete as well. And so when we're talking about a complementary pair of angles, we're really saying two angles which share a single vertex. So we have this vertex, for example, in this picture here. They share a single vertex, and when you add up their measures, we get the complete right angle. So the idea is I want to complete a 90-degree angle. So they add up to complete a 90-degree angle. So if I have two complementary angles, and if I know that one of them, let's say, is 38 degrees, then I could just say 90 minus 38, and that gives me this angle of 52, right? So we can complete the right angle by saying what is missing, what adds up to 90 degrees. On the other hand, when we see the term supplementary angle, to supplement an angle means that sharing the same vertex again, if I were to add another ray rotation, how far would I need to rotate so that I end up facing opposite directions, right? Forming a straight angle, which is what we have in this case here, okay? So we begin our rotation of 52 degrees, let's say. How much further would I need to rotate so that I end up facing the opposite direction? In other words, what is my supplementary angle partner here? And it would be found by taking 180 degrees minus however much I've already rotated, which is 52, and that would give me my 128. Okay. Now sometimes in your problems in your homework, they'll be a little bit more abstract. So instead of saying, here is one angle, find the complement or find its supplement, they'll use unknown variables to represent a portion of that angle. For example, take a look with me at what we have here in this picture. It says, can you find the measure of angle X? Okay. So what we see here is this square in the corner of our two angle rotations, which represents a right angle, which is 90 degrees, right? So that means that when I combine the first rotation with the second rotation, since they share a vertex and we're forming a 90-degree angle, these are called complementary. So that's the situation we're dealing with here. We have a complementary pair of angles. So we now know that when I add them together, we should get 90 degrees, right? So if we know that going into it, we could say our first angle, and I'll use the symbol we typically use for angle. It's that symbol here. So our first angle plus our second angle must add up to 90 degrees. But here they're representing the first angle as x minus 15. So I'll use parentheses there. And the second angle they're representing as x plus 5. So if you remember how to solve a basic linear equation, pause the video and see if you can get the right answer. So here we would add our 1x and our 1x. You might be thinking, what about the parentheses? Those are only important here if we actually had a negative sign in front or a number in front that need to be distributed. Otherwise, you can remove the parentheses and just get 2x, and then negative 15 plus 5 is negative 10. So now I'm looking at 2x minus 10 degrees should equal 90 degrees. If you want to get 2x by itself, remember you have to add 10 degrees to both sides. So this should become 2x equals 90 plus 10. Well, that's 100, isn't it? So if we end up knowing that 2 times x equals 100, what should x equal? 50, right? Divide both sides by 2. So x should equal 50 degrees. Now, that's just the answer for x, which is what they asked us for here. But if we actually wanted to describe what the two angle measurements are, our first angle is really supposed to be x minus 15. So this would be 50 minus 15. In other words, 35 degrees. And our second angle is supposed to be x plus 5. So 50 plus 5 is what number here? That's right, 55. Does that make sense that if you add 35 and 55, do you get 90? Yeah, you do, because 50 plus 30 is 80 and 5 plus 5 is 10. 80 plus 10 is 90. Okay, so we have shown an example here of how in your homework you might be asked to use the information that you know about complementary or supplementary angles to then solve for an unknown variable or to solve for the actual two angle measurements. All right, when you think you're ready, let's head to our next slide. Okay, example 1. Try this one on your own based on how we did our last problem together. It says find the measure of x in this picture. So what we see here is we have two rays which share a vertex, right? And it looks like we have a rotation at first. So here's our first angle. And that rotation is a certain angle measurement. Now, would this be acute or obtuse based on our previous definition? Yeah, good job. That's an acute. Good job, because it's less than 90. And then we have our second angle to continue the rotation. And this one is obtuse, isn't it? It's bigger than 90, but less than 180. So here's our second angle. And when I combine them, the first rotation with the second rotation, what ends up happening? I form a straight line going in different directions, don't I? So what does that mean? Yeah, that's right. These are called supplementary angles. They supplement each other in order to find a straight angle. Maybe that S will help you remember which one's which. So if we know supplementary angles supplement each other to complete the straight angle at 180 degrees, that means if I were to add up the measure, usually we write the measure of angle 1, this is the fancy way of writing it, M for measure, plus the measure of angle 2, we should end up with 180 degrees. So in this case, the measure of angle 1, right here, is x plus 26. So it's some unknown quantity plus 26 degrees. So we know that, x plus 26, while the measure of angle 2 is 2x plus 10 degrees. 2x plus 10 degrees. And when we add them together, we should be ending up with 180 degrees because they're supplementary. So again, if you have already done the problem, awesome. You can skip ahead to see if you got the right answer. Otherwise, feel free to pause the video and work this out from here yourself. Let's see how you did. Did you combine x with 2x, since those are what we call like terms in algebra? We add the coefficients together, since this is 1x plus 2x, which is 3x. Hope so. Did you take 26 and add it to 10, giving you 36, equaling 180? Okay, that means that we're at the place now where we need to solve for x, but first, to do that, do you remember the steps? That's right, you need to isolate the 3x by subtracting 36 on both sides. And you can do this in your head, you don't have to write it on paper. When you do that, you get 3x by itself and 180 minus 36. What does that give us? That's right, you should end up with 144 here. And finally, when you divide by 3, what do you get? You get your answer of 48, I hope? Good job. Now, once you know what x is, you could then understand the problem a little better by plugging x back in to the initial picture, right? So check and see, does this really make sense, right? If you take 2 times your x value and add 10 to it, what do you get? If you take x, which is 48, and add 26 to it, what do you get? Okay, so do your check by plugging in 48 on both sides and adding that up with the x, which was 48, plus 26. And see, does this really equal 180? If it doesn't, then you did something wrong, right? So you want to know that your answer makes sense. It's not just important that you can solve a problem, but it's more important really that you can set up a problem correctly that describes real life and then also makes sense of the problem. Okay. So once you've done a problem or two like this and you feel comfortable with this skill, let's head over to some more definitions on the next slide. Okay. So in this slide, we want to talk about what happens if you have 2 parallel lines. So that's what we see here. And one way that we'll typically write parallel lines is we'll use these double arrows here on each line. And that's telling us that this is a pair of parallel lines. So that's how we can tell that they're parallel, okay? If we have 2 parallel lines that are then cut by a third line, and this line is known as the transversal, okay, the transversal. It's kind of like an intersection that is formed when you're driving, right? You have a road and another road, and then a third road cuts between the two, creating new intersections, right? And so that's what we're having happen here. This transversal, let me get another color for us so you can visualize this better. This transversal is this third line. Now it can cut into or across these parallel lines at different angles, right? I just so happened to draw it this way, but it could have been a different cut in a different place, at a different angle with a different slope, right? But if we have the 2 parallel lines cut by a transversal, at each of those intersections, it turns out we form 4 different angles. And so that's what you see having happened here. We have this obtuse angle 1, this acute angle 2, this acute angle 3, this obtuse angle 4, this obtuse angle 5, this acute angle 6, this acute angle 7, and this obtuse angle 8. And if you were to actually do the complete rotation, angle 2 into angle 1, notice that they form a straight angle, or 180 degrees. And same thing with angle 3 into angle 4. That rotation is another 180 degrees, creating like a circle. 180 plus 180 is 360, right? So really we have these 2 circles created at these intersections. Now we're going to talk about those angles and what is the relationship that you'll need to recognize. First things first, we say if 2 parallel lines are cut or crossed, is another word for it, by this transversal, then the following angle pairs are congruent. And I don't think we've used that word yet, so let's describe it. When we say congruent, this is the symbol we typically use in geometry. It's an equal sign with a little tilde on top. Congruent just means having the same size or measurement. So when we're talking about angles that are congruent, we're saying they have the same measure, the same amount of rotation, okay? If we were talking about line segments, which are congruent, we're saying that they're the same length, okay? So the same size, same measurement is what we're talking about with the word congruent. So when we see here that we have these 4 different angles at each intersection, so a total of 8 angles that are formed, we're going to name them according to where they are in the place of the picture here. We're going to first talk about the pairs which are alternating, so switching, and they are interior angles. Interior is my first blank here. So what do I mean by alternating or alternate interior angles? What I mean by that for alternating interior angles is in between the two parallel lines, the angle 3 here, angle 4, angle 5, angle 6, those are all inside or in between the two parallel lines. So we would say those are our interior angles. Whereas our exterior angles, let me get another color for us. Our exterior angles, let's use one that you can see. How about this blue color? Let's make our exterior angles angles 1, 2, 7, and 8. So those are representing those angles which are formed at the intersections, right? Which are not in between your two parallel lines, right? They are outside, above and below, okay? So now let's see if we can make better sense of the term alternate interior angles. So when we're talking about these interior angles, we want to now focus on those which are alternating over the transversal. So angle 3, notice how this one is alternating over the transversal to angle 6, okay? So in this picture, we would say that the measure of angle 3 is equal to the measure of angle 6. Another way of saying that is angle 3 is congruent to angle 6. Why is that? Because they are alternating interior. And the same thing would hold for angles 4 and angle 5. Notice those are both obtuse. Well, they're going to have the same obtuse measurement. Angle 4 will end up being congruent to angle 5 in this case. Why? Because these are alternating interior angles. Okay, and you can measure them with protractors and compasses. You can actually create these and measure them and prove this fact. Okay, it's more fun if you have the time and those resources to do that. What do we mean by these alternating exterior angles? Alternating exterior angles. So let me find another color. We'll use black here. So for your alternating exterior angles, take a look at the exterior angle 1 right here. Notice that that is an obtuse angle, and if you were to alternate over the transversal, the next one you get would be external again, would be angle 8. So it looks like angle 1 will be congruent to angle 8. And similarly, angle 2 is acute and angle 7 is acute. So angle 2 will also be congruent to angle 7. Okay? So these would be our alternating exterior angles in this picture, meaning that their angles should have exactly the same measure. Okay? Now, in doing all of this, we actually have one more cool pair of angle types that you need to know about. And that occurs when you have two angles which are what we call opposite angles or vertical angles. So when we talk about opposite or vertical angles, we're saying that if we have two lines which are intersecting somewhere, it doesn't necessarily have to be like this situation with the two parallel lines cut by a transversal. It could be like the situation below here where we simply have two lines that are being intersected. Angles which are opposite of each other, directly opposite, right? Or on top of each other, if you like to say it that way, vertically above and below each other. Those angles are going to be congruent. Okay, so let's take a look in this picture here. Angle 4 and angle 2, those are both acute angles. They're both exactly the same size, while angle 1 and angle 3, notice I'm using tick marks to show the congruence here, are also the same size as well. And we can even see that that happens in the picture that we just did with the transversal that cut our two parallel lines. For example, can you help me identify the different pairs of vertical angles that we see? Wouldn't angle 1 and angle 4 be congruent? They would, wouldn't they? That's interesting. Which other ones would be congruent to each other? How about angle 6 and angle 7? Those would also be congruent to each other. That's very interesting. And then let's see which other ones would have to be congruent by the same property. How about, I'm running out of colors for you to see clearly. Let's use red here. Angle 5 and angle 8, those are vertical. They're directly above each other. And angles 3 and angles 2. So in the end, it turns out that there are actually only two different angle measures in the entire picture here, right? There's the acute angle measure and there's the obtuse angle measure. And using these pieces of information that we've talked about, alternate interior angles, alternate exterior angles, and vertical angles, you can come up with all 8 measurements pretty quickly. If you don't believe me, check out the next problem. Example 2. Find the remaining measures of angles 1 through 7 in this picture. So in this picture, we have two parallel lines, right, cut by a transversal, all right? Creating our 2 different intersections, which each have 4 different angles, so a total of 8 angles, okay? Here, notice that they've already told us that the measure of angle 8 is equal to 35 degrees, 35 degrees. So if we want to come up with the rest of them, we need to know the measure of angle 1, we need to know the measure of angle 2, the measure of angle 3, etc. Make some space down here. 5, 6, and 7, because they've already told me angle 8. So this is what we need to find. Okay, so to begin, if I know that the measure of angle 8 is 35 degrees, what else do I then know? Feel free to pause the video and see if you can answer all of these. I think you can. Well, I know, for example, that angle 8 and angle 1 are vertical angles, right? They are vertical angles. So you don't have to start there, but you could if you see it, which means that they are congruent to each other. So if angle 8 is 35, so is angle 1. So I did that by vertical angles. What else do I know? I also know that alternating exterior angles are congruent. So angle 1 is congruent to angle 5. So I could also complete angle 5 is 35 degrees. Anything else that I know about 35 degrees? That's right, it's also congruent to angle 2 because that's a vertical angle. So that also is 35 degrees. Good job. So far we have 4 different angles that are 35 degrees. That's not a coincidence. That should always be the case when you have 2 pairs of parallel lines that are cut by a transversal. We have angles 1, 2, 5, and 8 that are all 35 degrees. Is there a way that we could find the other 4 angles pretty easily? Well, I hope so. If we remember that straight angles are supplementary, so in this case, we have 35 degrees for angle 8, but if I continue that rotation to form angle 7, we have to form that straight angle in the end. So what happens when I take 180 minus 35? What do I get? I hope you say, yep, the right answer, which is 135. Did I say that right? Yes, I believe so. Okay, 135. So if that's 135, when I add up 135 and 135, sorry, one more time. Let me see if I wrote that right. I think I have 145. That's what I want, 145. I keep thinking, that doesn't sound right. Okay, if I have 145 plus 35, that should add up to 180. Okay, so once you have found that number from basically understanding supplementary angles, okay, you did basic subtraction, you get your number, make sure you do it right, unlike your professor. Once you get that right, you should be able to get the remaining ones. So that's 145. And then from there, angle 7 should be congruent to angle 6. Why is that? Vertical angles are congruent. Good job. So that should also be your 145. Okay? And then once you have that one, what else can you find? That's right, angle 3. Why is angle 3 congruent to angle 7? Because alternating interior angles are congruent. Very good. So that should be 145. And then angle 4, why is that congruent to angle 3, let's say? Because they're vertical angles. Good job. So that's also 145. So once you found the 2 basic angles, right, the acute and the obtuse, the rest flow naturally from those relationships. Okay. And again, you could always verify this using a protractor. All right, so on our last slide together here, I just wanted to summarize the geometry. Geometry is useful in many areas of your daily life. In our future videos together, we'll be talking about applications of geometry that are very useful to you. But it's actually one of the first discovered branches of mathematics. So I encourage you to check out the video that I've posted in your interactive notes that you see on the screen here, and it'll actually go through some of those cool applications that we'll be studying. All right, at this point, if you have any questions, please don't hesitate to reach out to me. Otherwise, happy practicing, because math is not a spectator sport. I'll see you next time.